Okay, so this is apply distributive property. Okay, and first off, we got to get some definitions down. So the first one is terms. Okay, and terms are simply parts of an expression that are added together. Okay, we also have coefficient. Coefficient is simply a very long word for the number in front of a variable. All right, and then we also have constant term, and these all go together, and you're going to see right here in a second. But basically, the constant term is a term that has no variable. Okay, so here's my example. We have negative 5x plus 3x plus 7, and basically we have three terms here. We have the negative 5x, we have the positive 3x, and we have the 7. Okay, now these two, the negative 5 and the 3, are coefficients. Okay, they're the numbers in front of the variable. This last one here, since it has no variable, it's not a coefficient, it's what we call a constant term. And the reason we call it a constant term is because it never will change value. So we know that we can always plug in a value for x, and that's going to change what this equals, because negative 5 times 1 is different from negative 5 times 2, and so on and so forth. But no matter what we plug in for x, this term is always going to be 7. Okay, so that's constant term, coefficient, and terms. We also have like terms. That's our last one, okay, at least for now. And like terms we're going to get into more detail later, but they're basically terms that can be combined, okay? And I'll show you how to do that later. But right now we're trying to apply the distributive property. And the distributive property looks like this. It's a whole bunch of variables, but it's actually pretty simple. So what it says is, if we have any number and we're multiplying it times any two other numbers being added together, it's the same as multiplying first. So if I multiply a times b and I multiply a times c, and then I add them together, so a times b plus a times c, we get the same exact answer. Okay? Or we can also do it if there's subtraction going on. So again, a times b and a times c, if we do the a times b first and we do the a times c first and then do the subtraction, we get the same thing. Okay, so let's look at some numbers so that it makes a little more sense. So example number 2, we have 8 times 10 and 8 times 10 plus 3. And again, since we're applying the distributive property, we can do this. And I do suggest that for a while you get used to writing those little curves, because it helps you remember what you're doing. So 8 times 10, we get 80. And then 8 times 3, we get 24. Okay? And just real quick, we could have actually added these together first. So if you did that, you would get something that looks like this. Okay, and this just means 8 times 13. That's some high multiplication there. I don't know if I would actually be able to do that in my head, so if I want to do this, I would probably do something like that. But over here, I can easily do 8 times 10. That's easy. And I can easily do 8 times 3. I know those are real small. So if I add those together, 80 plus 24, well, that's 104. Let's make sure these actually equal out. Okay, so 8 times 3, well, we said that was 24, and that means a 2 goes up here. 8 times 1 is 8. 8 plus 2 is 10. So yes, we get 104 equals 104, right? So again, it doesn't matter which way we do it. If we distribute the 8 or if we combine those terms, we get the same answer. Okay. The only time this happens, in example 3, we have 3x plus 2 in the inside. Well, here we can't add these two terms together. These are not like terms. Okay? Okay, these are not like terms. So that means we can't add them. So I have to distribute in this case. So I'm going to distribute the 5 to the 3x and to the 2. So 5 times 3x, that means I get 15x, and then 5 times positive 2, that's 10, okay? And actually, I'm done here. There's nothing more I can do. Again, these are also not like terms, so I cannot add or subtract them. Example number 4, now we have a negative number and an x, okay, on the outside. So again, if I want to distribute this, I can do it because I can't add these together, so I know I have to use the distributive property. I'm going to multiply those two together, and here we get a negative 3 times 4. Well, that's negative 12, but I also have this x and this x, and whenever we multiply variables together, x times x, we always get x squared, okay? So negative 3x times 4x gives us negative 12x squared. If you have any questions on that, make sure you ask them during class, okay? And I'll make that a little bit easier to understand. But we also have negative 3x times negative 2. Well, now we have a negative times a negative. Negative times a negative always gives us a positive. And we have 3 and 2. Well, that means we get positive 6. And we can't forget about the x. We have to be very, very careful to not forget that x. Okay? So if I look at these are also not like terms. And again, we'll go into more detail on that later. But because they're not like terms, that's as simple as we can get, so we're going to leave it just like that. Okay? And with these examples, we should be able to do our homework. So this has been the basics of applying the distributive property.